Welcome. So this is the study guide. The test looks exactly like this. So focus in. There are going to be some things that I'm going to say you need to have memorized, and then there are going to be some things that you can just use a graph paper, and that's going to be the easiest way. The first one, when you are translating, I think you'll get a graph piece of paper. It would be super easy just to have, if this is on a coordinate and you have -1, -10, and it's down here, to move it 2 units to the left and then down 6 and figure out where that is at on the graph. That's going to be the easiest way to do it for us. Most of us are visual learners. For some of us though, we're like, oh, we don't want to graph it, it's too much time. You just need to do -1. If you're moving 2 units to the left, well, left is in a negative direction, so it's going to be -2. And then if I have 6, if I'm going down units, that's also going to be, well, where do we start at? We started at 10 that you have right here at -10, and then we're going to go down -6. So where is this new coordinate at? It's at -3, -16. Remember, a translation is just sliding. So all I got to do. But if you have a graph piece of paper, that makes it easy. For rotations. Now, rotations are the ones that you need to know or have memorized. So, for the first one, it says rotate counterclockwise 90 degrees. So, rotating 90 degrees counterclockwise, you need to know the rule. So, I have all my rules right here, 90 degrees counterclockwise. All I'm going to do is I'm going to switch the order of it, and the first one right here, I need to change the sign. So when I'm doing this, all I need to do is switch the order. So now this becomes a 7, -3, and I need to change the sign of the first one right there. Okay. The next one says, well, we're going to go rotate clockwise 90 degrees. So clockwise, I'm looking here, clockwise, all I'm doing is I'm switching the order. So again, I write a -17, 10, and I need to clockwise change the sign of the second one. So instead of a +10, now it becomes a -10. And the last one for rotation that we have here is I'm rotating 180 degrees. And when I do that, if I look at my rules that I have right here, 180 degrees, doesn't matter which way I go. I keep the same order, so it's still 9, -4, but I need to change the sign of both of them. So a +1 becomes negative. A -1 becomes a positive. And there I go. So knowing those rules makes those really easy. Okay, the next ones we have reflection. Now for reflection, there are some of these that you can memorize and it would make it easier for yourself, but there's a lot of stuff to memorize. So like I think when you're doing over the y-axis, this is something you don't really need to have memorized. You'll get a graph piece of paper and it says the y-axis. Well, you would just graph here's 4, -7 that you have right here, and the y-axis that you have right here is this. It's the y-axis. And so all you have to do if you're doing this and you want to reflect over that, you just have to count how many over 1, 2, 3, 4 until you hit that you have here, and you go over 1, 2, 3, 4 that you have here, and that's where that new point goes. If you do know the rules that you have here, it can make this problem even quicker, because when you're going over the y-axis, all you are doing is you're keeping the same and you're just going negative. And that makes sense, right? Because we went left that way, and so it would be a negative. So on this one, all I'm doing is I keep the same order, so it's still 4, -7, but I just need to change the sign of the first one, so it becomes a -4, -7. Again, graphing that one would be the easiest. On 6, again, I would graph it. That would be the easiest way to do it. If I have -1, -8, it's right there, and you're going over the x-axis. That's right there. All you have to do is just count how many until you get up there. 1, 2, 3, 4, however many up there. I think that's actually, you're going to go up 8, whatever that is. But if you know the rules that you have right here, the x-axis, all you are doing is you're keeping the order the same, but that y you have to change the sign. So on this one, I still have a -1, -8, but on the y I need to change that sign, so that just becomes a positive. Again, I think for those two, so we don't have to memorize a ton, I would just graph it. That'd be the easiest way. But when you are getting into this y equals x, which remember that is y equals x, I'm kind of running out of room here. Make sure you guys have this. I'm going to erase it really quick. The y equals x is this line that looks like this. Here's a graph. It's that line that looks like that. And you want to reflect over it. So that's a diagonal line. So that one gets a little bit harder to do. So this would be definitely one I would memorize. And all you're going to do, how easy is this? You just switch the order. That's easy, right? So if I am on problem number 7, all I'm doing is just switching the order. So this just becomes, instead of 5, -2, it becomes -2, 5. Well, that was easy. Cool. So for those first couple, some you might graph, some you have memorized, but they should be really easy. Looks exactly like the test. The next one, you're reflecting over the y equals -x. Again, that is this line that goes like that you have right here. Again, it's a diagonal line, so this would be the one that I have memorized. All you are doing is you're doing the same thing that we did above. You're switching the two, and then you're changing the signs of both of them. So you are, on this one, switching them, so it becomes 4, -2, and all you're doing is switching the signs, so it becomes -4 and +2. Really easy, that's all you have to do for the answer. And then the last one says you are reflecting over the y equals -1. And so this one you need to draw. So let's draw it. Y equals -1. -1 is right here. There's that line that you have here. It looks like that. And again, you having graph paper is going to make this a lot easier. But if we are at this point at, let's say, -7 and +1 right here, and we want to reflect over this line, and let's make the line highlighted so we can see what we're reflecting over. We're reflecting over that. All we have to do is just count how many to the line. So if I'm here, I went down 1, and I'm going to go down 2. 2 and I hit the line. A lot easier on a graph piece of paper. But from here, all I'm going to do is just go down another 2. 1, 2 that you have right here. Okay. So this point is going to be still -7, and if I'm at 1 and I go down another 2, this would be 3, this would be 4, this would be -4 that you have here. Okay. And that's how you do it. What transformation always produces congruent figures? Explain. Okay, so congruent means that all the figures are going to be the same, so they don't change. So let's think. When I translate, all I'm doing is sliding the figures. So that one still is congruent. When I reflect, those still are congruent. And when I rotate, those are all still congruent. And this right here, translate, reflect, rotate, say are all congruent. And say angles and sides don't change. Angles / sides do not change. Okay. Well, which one does change then? Dilation. Dilation is the one where the angles stay the same, but that figure is either getting bigger or it's getting smaller depending on the scale factor. But translate, reflect, and rotate, they all still have congruent figures. Okay. The next one says we have a table, we have a trapezoid, and it tells me we start here, we end at this one. I know we end at this one because it has all the primes that you have here after a transformation. Now, it didn't tell me what type of transformation, but I want to know what is the coordinates of C. Well, let's just see from the ones we have if we can figure anything out. Well, if I go from -4 to -3, then I went over -3. And if I go from 2 to 0, then I just went down -2. Okay? That's not really a coordinate, but that's what I did. I went, maybe I should write this different. Maybe I should write, I'm going to go left 3. So I went left 3, and I went down 2. Okay? Well, let's look at the next one. I'm also going to go left 3, and down 2. And on this one, I'm going to go left 3 and down 2. It looks like I'm doing the same thing on all of them, left 3, down 2. Well, C would have to do the same exact thing. I need to go left 3. So all I'm going to do is it's going to be 2. When I go left, it's in the negative direction, minus 3. And 4, and I'm going to go down 2, minus 2. So this new coordinate right here is going to be negative 1, comma 2. Because all I did was went left 3, down 2. That's what C prime would be, following the pattern. Alright, so now we have one that says reflect over the y-axis. So here is my y-axis that I have right here. And we want to reflect over it. So the first thing that I need to do is I need to see that S and T, they are actually on the y-axis. So if they're on it, then I don't do any reflection. They're just going to stay there. This is still going to be 0, 5, and this is still going to be 0, negative 6. They're on the y-axis. But these other two I need to reflect over. And remember, we can remember the rules for reflection, but it's way easier just to count. Count, count, count. So if I'm here, and this is at negative 9, right, negative 9, negative 6. All I'm going to do is I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. I went over 9, and I'm going to go over positive 9. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Go right there. So let's say R, we're doing R first, is going to be 9. Now, I look, where am I still at? I didn't change at all on this one, so I'm still at negative 5. It's still at negative 5 that we have right here. And on this one, on Q, we're doing the same thing. We're going over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I was counting that, and I'm just going to go over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you get the idea. So this is still 9, and again, I'm still at this negative 6 that you have right here. So it's still negative 6. So all I did was just change the sign of that one, if you do remember the rule. But counting is easy, especially when you have a graph like that. Alright, dilation. Dilation just means we're getting bigger or smaller depending on the scale factor. This one, it tells me the scale factor is 1/2. Okay, so is it getting bigger or is it getting smaller? It's getting smaller. Less than 1, smaller. Bigger than 1, larger. 1 stays the same. So all I have to do with these ones, and dilation is pretty easy because you have negative 6, negative 4. Let's do it like this. B right here is negative 2, 4, and C is 6, negative 4. And let's use a different color. All I'm doing is just multiplying by the scale factor. And the scale factor right here is just 1/2. So I multiply each of these by 1/2. By 1/2. Okay. Alright, I think why it's asking DE, this was, I switched the pictures up. Let's say this is asking for B and C on this one. B prime would be negative 2 times 1/4 is a negative 1/2. 4 times 1/2 is just 2. So that's B prime. And let's say we did C prime. 6 times 1/2 is 3. Negative 4 times 1/2 is negative 2. Okay, again, those were off right here. But all you have to do is just multiply it by the scale factor. Cool. Alright, next one. It says write an algebraic rule for translation that moves a triangle 5 units to the right. Okay, so all these triangles are starting at an original one. And we're going to go to another one. Well, if I'm going 5 units to the right, that's in the positive direction. So I just do a plus 5. And then my y, it says I'm going down 9 units. Down is in the negative direction, so I'm going to go minus 9. And this right here is an algebraic rule. I'm telling all these coordinates go right 5, so add 5 to each of them, to the x units, and go minus 9 to all the y units. So that right there is the algebraic rule. Okay. Alright, next one. Alright, so first thing that I did was there are 2 transformations that are going to happen. here are my original units. I just looked at the graph and I just wrote them down really quick. I had them all matching up, and it first wants me to rotate 90 degrees counterclockwise. That's what this T prime is going to do. So here are my rotation rules, 90 degrees, and what did it want me to do? Counterclockwise, counterclockwise. All I'm going to do is switch each of them and then change the sign of the first one. So let's move this out just a little bit so we can still see it, just like that. So going counterclockwise 90 degrees. Counterclockwise 90 degrees. I'm switching them, so I go, this is a -5, comma, -6, and counterclockwise I'm changing the sign of the first one. So this is now a +5, -6. This is a -5, comma, -2, change the sign of the first one. This is a -7, comma, -2, change the sign of the first one. -7, comma, -7, change the sign of the first one. So I have the first one done that you have right here, and I could graph that. All I did going counterclockwise is I took this whole figure and I went counterclockwise 90 degrees. Now it's in that quadrant. I could graph these right here, right? I don't want to. It's going to just take me a little bit more time, but I could graph it if I wanted to. And if I did not know then once it's in this one, I just wanted to reflect it now over the y-axis, so over that one. So again, if I don't know my rules, I would graph each of these. I would have +5, +5, -6, +5, -6. And I'm sorry, I said before it should have been this one. This is clockwise, duh. But this way right here is counterclockwise. So yeah, it should have ended up here. Once I have it in here, then I'm just going back to the y. So all I got to do is just count however many units to that, and then I count over, and now I have it. I have it there. But if I have these rules memorized, so if I'm looking at right here, if I have them memorized, all I need to do is when I'm reflecting over the y-axis, I keep these the same. So it's still a 5, -6. All I need to do is change the sign of the first one. So this is a -5, -6. 5, -2 just becomes a -5, -2. 7, -2, it just becomes a -7, -2. This becomes a 7, -7, it just becomes a -7, -2. Again, if you do not know these reflection rules, because you don't really need to know it for y and x axis, just draw it. Draw it right here and just count. I just don't want to waste your time right now having me count, but this is what it would be. Again, remember there are two transformations that are happening. The first one is why we have this prime. When we have another transformation, that's why I have this double prime that you have right here. Again, these ones, the apostrophes, the primes, let me know what transformation happened first. Like this one I started with because there's no prime. This is my first one because it has only one prime, and this is the one that I ended with because it has a double prime, which means that two transformations did happen. Okay, on 16, very similar to the last problem, there's two different transformations that are going to happen. First, we need to reflect over the y-axis, and then we just need to rotate 270 degrees clockwise. And again, if you know the reflection rules, it makes it really easy. Again, if I don't know it, I just draw it. And again, this is just, I'm reflecting over the y-axis. So again, I'm going over the y-axis right there. So all I need to do is just count if I don't know the rules. Just go over 1. I go over 1, and that's where t prime needs to be. And this is just 1, -1. This one, r, I'm just going to go over 1, 2, 3, 4. 1, 2, 3, 4. This is where r prime needs to be, which is at 4, 4, -5. And the last one, I just need to go over 1, 2, go over 1, 2, and that right there is where I prime needs to be, which is 2, -6. Okay, again, those ones you don't need to have memorized. But the rotation ones you should, because I need to take this and I need to go 270 degrees, and it told me to do that clockwise. So 270 degrees clockwise, all I need to do is take these, switch the order, so it becomes -1, 1, and clockwise, I just need to change the sign of the first one. So instead of a -1, it becomes a +1. Switch them, -5, 4, change the sign of the first one. -6, 2, change the sign of the first one. And again, I had 2 transformations. That this is the first one, my reflection over the y-axis. This is my second one, a rotation. Again, that's why I have the double prime that you have right here. Alright, so what are the only times that a dilation will produce a congruent figure is when and again, you would write complete sentences on the test, but I would say when the scale factor is 1. Explain why. I won't write words, we'll just explain it. If I had a coordinate that was, say, 5, 1, and you had a scale factor of 1, all I'm doing is just doing 5 times 1 and 1 times 1, which means that it just becomes 5, 1. It didn't get bigger, it didn't get smaller, because 1 times anything is just itself. Again, you would explain that in your own words on the test. Alright, 2 left. Again, this should be A, B, C that you have right here. All we are doing in order to figure out what A prime, B prime, and C prime are is we are just multiplying them both by 1/4. So we'll say here is A, B is 4, 10, and C is 8, 0. Okay, and all we are doing now is we're just going to multiply each of these numbers by the scale factor, and the scale factor is 1/4. So times 1/4 times 1/4. So A prime is still 0, 0. So times 1/4 times 1/4. B prime, 4 times 1/4 is, again, fractions, you just put it over 1. So it's 4 over 4, which just is 1. This is 10 over 4. And again, you simplify it, divide top and bottom by 2, which becomes 5 over 2. If you wrote that as a decimal, that would be fine. Or as a fraction, doesn't matter. This is times 1/4 times 1/4, which is going to give me 2, 0. So all I got to do is just multiply it by the scale factor. Again, when it's a fraction, it gets smaller. When it's a number bigger than 1, it just gets bigger. Alright, and on the last problem, I wrote this out really quick just to save us some time, but here is P, R, and Q. There's the blue triangle, and again, I dilated it, so it got bigger. Here is P prime, Q, R prime, and Q prime. And all I got to figure out is what is the scale factor. So how much bigger did it get? Remember, scale factor is always multiplying. So what number did I multiply these by to get this by? Well, if you look, each of these, if I times each of these by 3 times 3 times 3 times 3 times 3, they all equal this one. So again, 1 times 3 is 3. 1 times 3 is 3. 1 times 3 is 3. 3 times 3 is 9. So I just had to figure out what that pattern was. A problem like this makes it easy if you write out what the P, R, and Q are and what the prime ones are. It makes it really easy to see the scale factor is 3. And again, I would just make sure that I'm looking, I went from P to P prime. P prime is the bigger one, so I know that I needed to get bigger. There could be a question that you went from this one to a smaller one, and again, if you're going from a bigger one to a smaller one, it means that this needs to be a fraction. But I went from a smaller one to a bigger one, and that's why it was 3. So I know Megon, not ideal. On the test, you will be able to use your flip book, and if you're stressing out that you have it here, please don't stress. I know it's not ideal with me not being in there, but I will give an opportunity to retake the test. The retake, I'll try and get these tests graded as soon as possible. You get about a week to retake it. So again, I'll be in here during tutorial once I come back next week to be able to clarify any of these questions, but the test will look exactly like this. So hopefully you know these. If you don't, you still have a few minutes. Rewind, go to the ones you don't know, ask the person next to you right here to quickly explain it. But if you know this, you should be able to get an A on the test. Okay, so again, don't stress out about it. Good luck. See you guys soon.